Picture this. Before a massive crane even attempts to lift a 1,000-ton steel tower into the sky, the absolute most critical work has already been done. Welcome to today's Explainer. We're going behind the scenes of plant construction to explore the unsung hero of heavy lifting, which is known as work preparation. We'll be uncovering the intense engineering checks and safety protocols that literally guarantee a multi-million-dollar lift doesn't end in disaster.
You know, out in the field, there's an unwritten, golden rule that veteran engineers absolutely live by. Preparation is 90% of the work. Basically, this means that if the work preparation phase is executed flawlessly, the actual lifting and setting down of the equipment is just a smooth, almost effortless formality. The real heavy lifting, that happens during the planning phase. We strictly call this work preparation, and it's the absolute backbone of any successful installation.
Now, you might be wondering, why do we need such an incredibly extensive prep phase? Why can't we just hook up the cables and hoist the machine into the air? Well, if you're new to the field, the stakes are unimaginably high. We are talking about massive, heavily engineered plant equipment weighing hundreds of tons. This operation is incredibly dangerous and, let's face it, immensely expensive. A single miscalculation, a slight shift in wind, or even a slightly unlevel foundation can derail an entire project, or worse, cost lives. So, to make sure a lift goes perfectly, we follow a strict roadmap. Today, we'll cover, first, the key to successful erection. Second, thorough plan and drawing reviews. Third, checking site and foundation conditions. Fourth, equipment and safety inspections. And finally, verifying we're ready for the heavy lift. All right, let's dive right into part one, the key to successful erection. It's really a tale of two sites. On a fully prepared site, the entire erection process is safe, efficient, and keeps everything right on schedule. The equipment just glides into place exactly as it was modeled in the 3D designs. But contrast that with an unprepared site. You're suddenly looking at dangerous conditions, massive delays from renting idle cranes, and severe structural risks to the equipment itself. Simply put, if you skip a single step on the prep checklist, you are actively choosing that second, disastrous scenario. Moving right along to part two, thorough plan and drawing review. This is where the engineering magic happens. There are two absolutely crucial engineering terms you need to know here: the rigging plan and the center of gravity, or C.O.G. Think of the rigging plan as your ultimate playbook. It takes the equipment's exact weight, dimensions, and crane radius to dictate the perfect lifting strategy. Then you have the C.O.G., which is the exact balancing point of that massive weight. If you attach slings incorrectly relative to the C.O.G., the equipment could dangerously swing midair, causing catastrophic damage. And you can literally see the result of that math right here. Notice that center of gravity marking painted directly onto the side of this horizontal vessel? Engineers calculate this point with extreme precision during the fabrication phase, considering all the internal components, so the riggers on site know exactly where the balance point is before they even attach the crane hooks. Next up, part three, site and foundation condition check. Time to leave the blueprints and get our boots dusty. Massive equipment obviously requires a flawless space. We physically walked a site to perform three critical checks. Step 1, we verify the anchor bolts perfectly match the equipment's base plate. Step 2, foundation chipping. We actually have to chip away the smooth, weak top layer of concrete, what we call latents, so the final structural grout has a nice, rough surface to bond with perfectly. Step 3, we confirm the padding is completely leveled out to receive all that weight. This is the gold standard we're aiming for. Look at how perfectly seated the base of this vertical equipment is. You can see those thick anchor bolts securing the flange, and if you look really closely underneath, the leveled padding is supporting that massive load. This foundation is now 100% prepared to handle the intense operational stresses once the plant is actually running. Which brings us to part 4, equipment and safety inspection. These are our final external checks. We are almost ready to fly. But right before the lift, we inspect the lifting lugs for microscopic cracks that might have happened during transport. You also have to confirm optimal weather. Even the most perfectly rigged crane will be immediately shut down if wind speeds exceed strict limits. Typically, anything over 20 miles per hour is a hard no-go. And finally, you have to conduct a TBM. Let's zoom in on that TBM, or toolbox meeting, because it's absolutely vital. This is the ultimate safety checkpoint. The supervisor gathers every single crew member, from the crane operator in the cab to the riggers on the ground, and verbally aligns them all on the lifting plan. They discuss who signals the crane, potential pinch points, and emergency protocols. Because out there, flawless communication literally prevents accidents.
And finally, part 5, ready to lift heavy equipment, the absolute peak of our preparation. At this point, if you're running your first site, you can look at your checklist with total confidence. Engineering, rigging plan, and C.O.G? Approved. Foundation, chipping, and anchor bolts? Verified. Weather clear and safety inspections done? Check. Your rigging crew is fully aligned and standing by.
The prep is flawless. Every single variable has been locked down, and 90% of the hard work has been successfully completed behind the scenes. So now, after all of that incredible coordination, are you ready to watch the crane hook up and finally lift this massive equipment into the sky? Well, that stunning equipment erection phase is exactly what we'll explore next time. Thanks so much for joining me today, and keep exploring.